Good morning, everyone. My name is Amy DeWitt. In this term, we worked on electronics. My design project I decided on was a weight loss lock. How I came across this problem was quite simple. It was through friends always complaining about their weight. So I decided to create a locking mechanism that only opens when you reach a certain number of steps. My problem statement is to design and develop an Arduino-controlled locking mechanism for pantries, refrigerators, and snack boxes to prevent access to food for people who want to lose weight and live a healthier lifestyle. My research I did was to see how many steps would be required for one day, and that would be 10,000 steps. And other similar projects, which was case safe, with a container which uses a timer, and different types of locks. How it would be applied into the real world would be by helping others to live a healthier lifestyle through locking the food inside of the container, and the lock is adaptable to practically any container or unit. It provides motivation to people who want to live a healthier lifestyle and also to get steps in. The key components I used was an accelerometer, which picks up small movement, and a 3D printer to print my lock and my wearable, and the Arduino Uno, which is the mini microcontroller that programs and controls button switches and other electronic devices, in the 4-digit display. My innovation would be the fact that the pedometer is the key to opening the box or container, and it's low costing towards K-Safe's product, which is ranging from 1,000 to 2,000 Rand, and forces the user to get steps in before access to food. It motivates the user as well because they can have a clear goal and see how many steps they achieve. This is my hand-drawn sketch. This is where the Arduino is. That's the servo, and that's where the accelerometer is, and that's the 4-digit display. This is my CAD sketch of the lock itself. That's where the servo would go in, and that is the latch that would go on top of the server, and that would be where the latch would hook onto. This is the CAD sketch of the wearable. There you can see the Arduino is inside, and that's where the battery would be, and that's where the elastic would go by the 2 slits on the side. And this is a loop of how I made it on CAD. So, yeah. And this is the circuit diagram. It's much more clear than my hand sketch, so everyone can see this is the way the Arduino is, the accelerometer, the servo, and the 4-digit display. The alternatives I considered was wanting to have the lock to be inside of the box and not sticking outside, and lights to indicate whether you're already by your set goal of how many steps you have or not yet achieved. And here you can see my product testing. I used my phone to check the accuracy, and I used my friend Sean to test my if it counts the steps properly. It opened slowly but surely, but it got there. He was really looking forward to the snack. The tools I used was a 3D printer to print majority of my parts, and a soldering iron to solder the pins into the accelerometer, and Fusion 360 to sketch out where I want everything to be placed, and Arduino IDE to program the Arduino, and needlework to sew the elastic that is on the sides, and the breadboard while I was busy testing everything at the beginning. And the soldering iron, it took me a while to understand that you have to put it off if you're not going to use it. Arduino IDE, with the syntax, it has to be correct, otherwise nothing would work. And needlework skills, don't use a sewing machine with elastic. And always check the wiring, because you can make a mistake quite easily and there can be loose wires. And make sure that your 3D prints come out correctly, and always check them consistently. And here you can see that this term this term was a tutorial project, and it was building a line following car. It took me quite a while to figure everything out, building everything, but it came out pretty good, but it just came out with a little bit of an attitude, as you can see. It has a mind of its own, but yeah. And with selecting and planning everything, my components from the beginning, I did a lot of testing, and separately testing everything with different objects and different materials and components, and then creating a circuit diagram how I want everything to be placed and assembled, everything, and then tested everything at the end. So as you can see in the picture, that is K-Safe's container that uses a timer with the days, the hours, the minutes, and even the seconds. And I had to do research about theirs, and I also did research about other different types of locking mechanisms that already exist. And how I applied it to mine was through figuring out that a latch would work better, and an accelerometer would be better suited, because if you have a timer, you can laze around on the couch, watch TV, and not do any exercise. While with the accelerometer, you can at least get steps in. And with the placement of where would the wearable be placed, the reason why I said the waist is because when you have it on your arm, you can cheat easily to getting steps in by just moving your arm around. But if it's around the waist, you're forced to walk around. This is my activity log for this term, and this is my theory, my tutorial project, my PPD, my practical, my personal experience, and my project and extra information that I learned throughout this term. Most impactful PPD would be Roy Bhaskar identifying and addressing the hidden mechanisms. Bhaskar is a philosopher that believed that reality exists whether we understand it or not. And it's through that type of thinking that it reminded me to stay curious and humble, and knowing that reality is deep and complex, and that there's always more to discover. The technical difficulties I had was figuring out finally how to program the accelerometer, because it took me quite a while, and the wiring to make sure that there's no loose wires. The latch, to reprint it so many times because I got the measurements wrong. And the servo, I had the wrong servo without knowing it, and I soon had to switch it out with a different one. And dyeing fabric because I had a white elastic at first and I wanted to dye it a green color, and then the glove broke, so my hands were stained green. So don't worry, I didn't work that hard that my hands started turning green. The technical successes is finally getting the digital display to work with the Arduino and the locking mechanism to work, and also the accelerometer to work with the Arduino, the digital display, and the accelerometer, and making everything easier from the beginning for myself by separating everything so that I understand it before putting everything at once just together. And I hope that for the future it would be a mobile app and not where people have to walk around with a box the whole time around their waist, and a lock that's inside the box and Wi-Fi so that the Arduino can communicate to the lock itself, and that the user can set their own amount of steps that they want and how they want to equal out to the calories that they're putting into their body. This is the bill of materials. As you can see, the Arduino Uno is so far the most costly on the bill of materials, and the total would be altogether 381 Rand and 42 cents. And now for the demonstration. So for now, I just put it up to 50 steps so that everyone can see how it will work. Okay. Good. Okay. Yes, please, I'm getting nervous. I'm just getting nervous. I'm getting the shivers. So it would work like this. So it picks up the small movement. Somewhat, yeah. So I'm already by 30, and so now it's just trying to get to the 50 mark. But sorry. There we go. And then just by connecting these 3 wires, it opens. So was a long wait, but okay. And I would like to thank Nick for helping with everything, for Tani Almery for pushing us to our limits, and for the automation employees who gave me the idea, and for my classmates for always helping me through my struggles. Any questions?